welcome you all once again. I'm Meghamala, working assistant professor from Institute of Aeronautical Engineering. So today's topic is about discussing the definitions and terminology from module 1. So till now we have discussed what are the different modules. Out of 5 modules, we have discussed many topics pertaining to the different modules. So now today's topic, we are going to discuss something, the definitions of module 1. Okay, module 1 is all about the Verilog as HDL. So we will see in this Verilog as HDL what are the different terms and the terminologies and the definitions of particular definitions of different various terms, right? So coming to the first one, let's define HDL. So what is this HDL? HDL, as we all know that so far we have studied based on this HDL and Verilog, right? So HDL is hardware descriptional language. So this hardware, the Verilog hardware descriptional language, it is a language that describes the behavior of the electronic circuits, most commonly digital circuits. Yes, we are saying that this Verilog or as a HDL, hardware description language, it is a language pertaining to the behavior of the electronic circuits, okay, or the digital circuits. It gives out it just gives the knowledge about the behavior of the different circuits, different electronic circuits based on different algorithmic levels or as an abstraction level that we are used. So that is nothing but the hardware descriptional language. Here we will be describing the each and every module that we are come up with. Okay, for example, let's say half adder. So regarding this half adder, we are going to we will derive what is half adder. Okay, using the hardware languages, we are going to derive what is this hardware half adder and how it is going to work out. Okay, using what sort of code or else using the terminologies that pertaining to the choices that we are making in order to develop the circuit hardware. Sorry, half adder. So this is all about the hardware descriptional language. And then one more term we have come across in module 1 is about the Verilog. So the module 1 name itself says Verilog as HDL. Verilog as HDL. So HDL, now we are determined with HDL. HDL is a hardware description language. It is a language where it helps us to describe the behavior of that particular module. So in the classes, in the module 1, already we have discussed about the behavior. Here we are saying that it describes the behavior, right? So we have discussed there are 4 level of abstraction levels. We have 4 level of abstractions in the HDL. They are nothing but the gate level abstraction, behavioral level abstraction, circuit level abstraction, and as well the switch level abstraction. Okay, so these are the 4 levels of abstraction. That means being a designer, I can choose, I can design my circuit out of this anyone by choosing anyone out of this 4. Okay, 4 level of abstractions. And then what is a Verilog here? So Verilog is a hardware description language itself. Verilog, it is a hardware description language where it used for describing the digital systems like networks or network switch or microprocessor or memory or flip-flop. So here it is a bit different or else it is we can discriminate it with the HDL because Verilog, it is a very large integration circuit, a hardware description language. So here in this Verilog, we can design the modules. Okay, we can design the modules in terms of memory elements, in terms of microprocessors, in terms of logic elements, logic devices, and also in terms of switches, different types of switches. And in order to develop all these kinds of digital modules, we have to go with certain describing certain level of abstractions, right? We have to go or else we have to design it with certain level of abstractions and that abstractions also we meant with respect to gates behavior, circuit level and switch level as well. Okay, and then coming to the third definition, what are the operators? So here in the module 1, it is like we recall what we have discussed in the module 1. So we have come across the operator, the word operator. So here operator is nothing but they are helpers. They will help us to analyze, or else they will help us to analyze the given code. Okay, that means what? They will help us to analyze the mathematical expressions and all those things. So coming to the operators, we have several operators in the Verilog as well, because in the Verilog we have different libraries. So that some libraries are pertaining to the operators and some libraries are pertaining to the gates as well. So here when it comes to the operators, they perform some operations. Obviously each and every operator pertaining to this Verilog VHDL, we see that they perform some operations, one or more operands with an expressions. Obviously, it's clear that certainly in the expression we come across operators and the operands. Operands are related with the operators as well. For example, here I have C is equals to A into B. So I can say that here this is called the operator. Operator. A and B are nothing but the operands. So in whole, I can say that the operators, it performs some operation. That means here C is equals to A into B. So here it is performing some operation. Multiplication operation is being performed between two operands, A and B, between two operands. So it performs an operation on one or more operands. So sometimes there are few different operators we have. Few operators, they consist only one operand, whereas few other operators, they consist more than two operands. Some operators, they consist three operands as well, A, B, C. And some operators, they consist two operands. And some, they goes with only single operands. So here, an expression combines operands with appropriate operators to produce the desired functional expression. So in order to produce a desired functional expression, with the help of operators and operands, we can easily construct, or else we can easily obtain the expression. And then so here coming in the operators, there are several types of operators we can see in Verilog. So let's go first with the arithmetic operators. So arithmetic operators are see here you can see these are the operators, and this is a description. So here we see A plus B. Okay, A plus B is operation. That means addition operation. As it is arithmetic operations, we are going with several arithmetic levels. That is addition, subtraction, division, multiplication, ampersand. Okay, ampersand and to the power of B. So here these are the few arithmetic operations, and and then we'll move forward. This is a relational operators. So in the relational operators, we will relate. Okay, it will help us to relate between the two operands. So we can say the greater than, less than, or equals to, less than or equals to, and greater than or equals to. These are very simple to understand and easy to remember as well. Remember that in the operators we have like we have discussed the arithmetic operators, relational operators, where it relates between the two operands, and the third one is the equality operators. So equality operators, like here if you observe, A triple equals to B. So it means that A equals to B including X and C. And that means what? This is a equal operator, and here it is not equal to B. Okay, you have like this, right? So it is not equal to B, and here you can see that the result is unknown. So here you have only double equals to. It means that the result which is obtained when you equalize both operand, and that result can be unknown. And as well here the fourth one, if you observe A not equal to B, so the result is also unknown. These are the descriptions or the comments with respect to this operator. So here equality operator meant that it is equals to or not equals to, that we can say. And the fourth one is logical operator. So logical operator, here we see A ampersand A and B. That means what? It equals to, it evaluates to true if A and B are true. So if A and B are true, then obviously it becomes expression goes with the true condition. And then A or B. Okay, so this is the logical operator we are representing with AND as double ampersand and or as double bar. And then here if you see, it converts non-zero value to zero and as vice versa. So here if you come across anywhere like this, not, so it means that it converts a non-zero, or else from 0 to non-zero and from non-zero to 0. So these are nothing but the logical operators. So likewise, we have different types of operators: bitwise operators, relational operators, concatenation operators, and so on. And now, coming to the fourth definition, here what are the parameters? So in order to construct any sort of code, or is in any kind of language, we will be observing few variables, or else few parameters are required, right? So here we will see what is a parameters. Parameters are an attribute to Verilog HDL module that can be altered for each instantiation of the module. So here what this and this particular definition regarding parameter, it's saying so that in order to represent the inputs and outputs of a particular circuit, okay, that means what, for example, if I'm considering any half adder, okay, in this half adder I required A and B as input, C as a sum, and C as carry, right? So these are the outputs and these are the inputs. So in order to represent input and outputs, I can say that these are nothing but the parameters. So parameters, these are the attributes to the Verilog HDL module, so that it can be altered for each instantiation of the module. So here we can change, okay, we can alter for each instantiation. For example, here in my first in the very first step, I'm just instantiating the inputs and outputs as well, okay. But the next in the step 2, or else in the second instantiation, I may consider only inputs, okay, I may not consider the output, okay. It's our wish. So whether you instantiate at the initial state, if you want to instantiate the input variables, or else if you instantiate the output parameters, it all depends upon you. But the parameter says that they are the attributes. That means what, they are the most needed things in order to write a particular program, okay. So these attributes represent constants and are often used to define variables, width and delay values as well. So here these parameters, so the parameters can be in terms of delays, okay. That means what, for example, my output is going with a delay of 20 nanoseconds, okay, 20 nanoseconds delay. So how can I represent this delay? I can represent using the hash code, right? So this is a parameter I can say. And now we can represent the parameters in terms of delay, or else in order to represent delay, I can use some parameters, which is like hash code. And then if I want to represent some width, or else if I want to if I want to instantiate the width of a particular material, so I can represent W as 0.1 or 0.2 mm. So these are nothing but the parameters. They are specified to they are specified to the constraints of the design, okay, design of a circuit. Then in the module parameters, so in the parameters we have different types of parameters, we can say. So module parameters are nothing but it can be used to override parameter definitions, okay. That means what, here such kind of module parameters, we can override the parameter definitions within the module, okay. Within the module, if you want to alter or if you want to change some parameters, we can do it inside the module itself, okay. Inside the module, if you want to alter any sort of parameters, so that can be easily done. And this makes a module have a different sets of parameters at compile time. So at different intervals of time, whatever the changes that we have made to this module with respect to the inside, and they can be seen at the output as well. So the changes which are the changes with respect to the parameters inside the module, if any changes changes have been occurred, then such parameters are nothing but the module parameters, okay. Then the other type of parameters are overriding parameters. Overriding parameters are nothing but it can be overridden with new values during module instantiation. So it means that here the module overriding parameters. So these kind of parameters can be overridden, right? For example, here see in this particular example, in this particular code, if you observe module, okay, it's a keyword, right? Module is a keyword. So in order to write in order to write some code, we need the keywords. So keywords are nothing but they are the main essentials in order to write something, some particular code. So module is a very keyword, and TB is nothing but the test bench. So test bench of a particular module that you are considering. So here, module instantiation override. As we are talking about the overriding parameters, we will see the module instantiation override. So here in this example, we have seen that design input, okay, with some delay. So here, bus width, the width of a bus is 64 and the data width. So this is what I instantiated. This is nothing but the module instantiation override. And now we will see how are we overridden, how these parameters are overridden. That means what we replaced with what sort of parameters. So here if you observe, use of def param to override. So here instead of design IP, what am I doing is I'm just overriding, okay, I'm just overwriting with a keyword, right, def param. So D naught into first in first out, depth of 128 and end module. This is how I can override. That means if you with something I have written and now I want to override this parameters. How can I override this? By introducing some keyword like. So keyword, we are talking about the width for bus and as well as the data, right? So together, that is a width of a bus and data, I am overriding by using a parameter called def param with respect to the depth of the both width and width of bus and as well as data. I'm just representing, or else I'm just overriding with respect to first in first out depth with some value 128. So these are the parameters. That means in the overriding parameters, I can override the parameters which is present before. Then we'll move on to the fifth one. That those are nothing but the what are the unary operators. So unary operators, as the name itself says, that only one operand we can make use of, right? So only one operand. So unary operators need only one operand. So as the name indicates, it's unary, one. For example, arithmetic operators for representing, obviously for the arithmetic operators, in order to represent, we goes with plus, addition, subtraction, isn't it? Multiplication, division and all, right? So these are nothing but the unary operands. So negation, okay, for the arithmetic operators, we represent like this. And for the negation operator, obviously, we will represent the negation sign. Okay, and reduction operation, these are the, what do we say? These are the operators that we, this is how we represent for the negation of, reduce operator. So here, we will see the new unary operators. So the operator and ampersand is nothing but the and we use it for this. This is nothing but the only one. And now for NAND, how can we represent the NAND? Negation and. Okay, this is NAND and NOR, or so only bar, and then NOR, negation of a bar, and then XNOR. This is how I represent XNOR, negation of bar or else, okay, negation of bar or else bar and negation. So these are nothing but the unary operations where they need only one operand. And reduction operators are unary operators. So another kind of the operators, in the operators, reduction operators are a kind of operators. So those reduction operators are nothing but the unary operators. They perform a bitwise operations. Okay, so they perform a bitwise operations on a single operand to produce single bit results. So as the name indicates, it considers only one single operand. So the result will get in only in terms of a single bit. Then reduction unary NAND and NOR operators, NAND and NAND operators, they operate as and OR respectively with their output negated. So here this sentence says that if you want to observe the output of this NAND, so how can I go with NAND is nothing but it is AND plus NOT, right? AND plus NOT. So and NOT. It is nothing but the NAND. So here if you observe, negation of AND is NOT. negation of and is NAND. Likewise, negation of OR is NOR. So the reduction unary NAND and NOR goes along with the operands, or is the operator which operates and OR respectively. So this is how we will represent the unary operator. And what are the binary operators? So the binary operators requires two operands to perform operations, right? So unary operator requires only one operand. One operand is meant for unary, whereas for binary it requires two operands. So the majority of the operators available in Verilog requires two operands. So obviously, if you want to if you want to get some results out of by using these binary operators, you need two operands. Okay, two operands are available in the Verilog, and it requires two operands, and that is meant for the addition, logic operations, multiplications, and so on. So A plus B, A minus B, right? A multiplication, A product of B. So here, these are the binary operators. Two operators are needed for it. And now we will see the concatenation operator. What does this word concatenation operator means? We all know this concatenation means clubbing, right? So getting together. If suppose I'm having A as 0, 1, 1, 2 and B as 4, 5, 6. So the concatenation of AB is 0, 1, 2, 3, 4, 5 and 6. So the concatenation operators are they are expressed using the brace characteristics. Yes, brace characters. So flower braces, and with commas separating the expressions within. So here, obviously, see in this example, I concatenated A and B, right? So in the flower braces, I have to represent what is there in A with the commas in between. A and B as well. So the example, if you observe here, AB 3:0, C and 4, it's a 4-bit of binary value 1. That means what? If A and C are 8 bits, okay, if A and C are 8 bits, the result has 24 bits. Okay, the result has 24 bits. How come it's 24 bits? See here we have the unsized constant numbers are not allowed in this using concatenation. That means using this particular example, we can understand how the concatenation representation takes place when you write a code. So it's a module, goes with the very first step, module representing the device or is a circuit that you are using. So the module concatenation operator. Okay, and always remember that if you are starting or else in the coding, when you're writing some code, always at the end of the code semicolon is must. And then now what am I doing is initial begin. Okay, I'm just starting up. Why? Because I have to represent here, or else I have to show something onto which the concatenation onto which I'm considering, or else I'm clubbing both the things, right? So here initial begin, concatenation, and the display, okay, display of 4-bit of binary values and percentile 4-bit and 4-bit, then with a delay of 10 nanoseconds finish. Okay, and then I have begin and then I'm ending end module. So here out of this from this example, I'm just concatenating A, B, C and D. Okay, so totally when I concatenate each of 4 bits, right? Each of 8 bit, right? So each of 8 bits, so the result I'm going to get is 24 bits, where here this display in the 5th row, the display means that in order to, in the test bench expressions, or in the test bench coding, if you want to see, or else if you want to see with how much of delay the input and output are, or else with how much of delay the concatenation taking place, if you want to observe that, then you have to write in the code the display. Okay, so here I have mentioned the delay as 10 nanoseconds of delay. So with the 10 nanoseconds of delay, I am just concatenating A, B, C and D. Okay, so this is about the concatenation operator. Remember, concatenation operator are represented using flower braces and the commas in between the operands. Then What are the ternary operators? So the name indicates ternary operators. It requires 3 operands. So the ternary requires 3 operands. For example, conditional operator. Okay, so for the conditional operator, the conditional operators can take with respect to question mark and as well as the colon. So the conditional operator has the following C-like format. Why we are comparing it with C-like format means we know that like Verilog is very much or else it is very close to the C language, right? So whatever we can compare easily, the similarities we can find when you compare the C language and as well as the Verilog language. So the C language is of course related to the software language, whereas Verilog language is related to the hardware language. But we can see the similarities when you compare. That means in the C language you will have variables as well, and in the Verilog language we have the variables, and in the C language you have different primitives. So as well in the gate also, in the Verilog also you have the primitives as well. So that's the reason we can compare it with the C language. So coming to the conditional operators, I'm saying that the conditional operator has the following C format. So if you see, as I said you, this ternary operator requires 3 operands, right? So how 3 operands means totally based on the conditional operator. If it is true or false, if it is false, and then the condition goes with the true. So the condition expression true. If it is a conditional expression with the conditional operator true and expression. If it is false, goes with the expression. So it is just it goes as per the conditions required. If it is true, then the if it is true, A and B, okay, colon, C and B, colon, and D. If C is true when you compare it with B, then B must be false when you compare it with the D. So it requires 3 operands. C, B, D are the 3 operands, and call the 3 operands, where here the conditional using the conditional operators we can easily or else we can easily get to know based on the conditions we can easily get to know which statement is true or false. Then the true expressions or the false expression is evaluated and used as a result depending on what condition expression evaluates to true or false. So here using the expressions true, if it is true or false, the true or false can be evaluated and the result it can be used as a result. Okay, so the output that you are observing the condition as true or false, so it can be used as a result depending upon what condition expression evaluates. So depending upon what condition that you are considering and what is the output that you are getting out of that condition, and it can be evaluated under using conditional operator and using the conditional operator. And now we will see the replication operator. So the replication operators are, see if you observe here, we have an operator and description, replicate value n times. So here I see something 2, it's given like n in m. So it replicates. So replicate operator is used to replicate a group of bits n times. Okay, group of bits n times. If you're finding same type of number repeatedly, okay, that means what? It replicating how many types of number, how many times of that number is repeating in that particular set. That is all about the replicating operator. Using replicator operator, we can easily find out, or else we can easily represent the number which is repeated in that particular set. So here if you observe m, so it replicates value n times. So this value m is replicated, or else the value m is repeated n times. Okay, for example, the value is 3. The value 3 in the set is related, or it's repeated twice. That means what? Out of the set. So here in the set I have 0, 2, 4, 2, 5, 3, 0, 2, 4, 3, 5, 3 and 2. Sorry, 5, 3 and 4. So from this set, I now using replication operator, I want to know which number is repeated. So I can say that 2 times the number 3 is repeated in the set. So this is how I can write the replication operator. So the replication operator is used to replicate a group of bits n times, right? N times. Then, say you have a 4-bit variable and you want to replicate it 4 times to get a 16-bit variable. Then we can use the replication operator, isn't it? So 4 times of 4 bits. So how much time? 16 bit. 2 times of 3 bits. So how many times? 6 times. 6 bit, right? 3 plus 3, 6, right? How many times 3 is repeated? Twice. So using replication operator, this is how I can represent in my coding part. Then move on to the module. So what is a module? So if for each, in order to describe the circuit that you have made, that you have designed, we are representing it with a module. So module is nothing but it is a name, just a name given to any system, considering it as a black box with inputs, output terminals, and the terminals of modules are referred as ports. So if you are, for example, this is my product, and now I'm going to describe this product. So what can I say? I can take this name as a module. So this is a module. So for this module, some inputs I have to give and I'll be getting some outputs, right? So this is nothing but a module. So the module is nothing but it's a name. The name given to the system, considering it as a black box with inputs and output terminals. It has some inputs and it will be like some outputs we get. So the terminals are referred to as ports. So for this module, these are the input ports and these are the output ports. So this is a module, right? So entry of the bits are nothing but is the entry of the bits, and this is the exit of the bits. So here you observe this is a module. For this module, X and Y, Z are nothing but the inputs, and F and G are the outputs. So in order now I have to write the code for this module. So how can I write? I have to write the module, the name of a module. So the module is M1, the name given as M1. That means if this is my module, I can give the name as pen, right? So I have to write the module name pen. So likewise, he has given the module name as M1. And now here, after giving the name, this is nothing but the bracket. In the bracket, he has to, or else we need to mention the inputs, outputs, and in-out ports. Input ports, output ports, and in-out ports. Why? Because the module consists of some inputs, some outputs, and input and as well as the output ports. So here the representations of the input, output, and in-out ports can be given in the bracket. So here I am giving. So he has given, as per this diagram, he is given that input as X, Y, and Z, right? X, Y, Z. Outputs as F and G. So now, after mentioning or with respect to the module keyword, the next step goes with the statements. So this is a statement. In the statements, individually again we can represent the input ports. Individually, I can represent the output ports. And after that, I have to description. I have to describe now. Okay, for example, if I'm considering an AND gate. Okay, so now for the AND gate, I have to give the names A and B, and C is the output. And what is an AND gate? C is equals to A dot B, right? So now in the module, I have to write as module AND gate. My inputs are A, B, output is C. And then after this, I have to mention with a statement called begin. Begin. Now I have to write the statements. In the statements, I can mention again inputs as A, B, output as C. Later, now I have to describe the gate. What is the functionality of a gate? Functionality of a gate goes like this. C is equals to A dot B. And then I need to end. Then end module. So this is how I can write a particular code. So here, description end module. If you are starting with the code with the module, then obviously you have to end with the end module. Okay. So then each Verilog design starts as a block diagram called a module in Verilog. So in the Verilog, if you are designing something, okay, basically this is a pen, right? So before it forms into a pen, I have to clearly mention that in terms of module. Okay, in terms of a square box where I'm giving what are the inputs and what are the outputs. So after writing or else after drawing in terms of block diagram, and then I have to compile, and then I have to verify. After verification, I have to go for the simulation, and after the simulation, I have to go for the generation. And finally, I'm going to observe, also finally I'm going to get this module, and that module I'm naming it as a pen. So that's how all the digital electronic circuits will come into existence. And then finally, start with input output signals, then describe how to produce outputs from the input. So in the module, we have to, in the coding part, we have to describe how the output is obtained from the input. So this is all about the module. Now, coming to the white space. So white space are nothing but the lexical token. It is one of the lexical tokens. In the Verilog, we have 7 kinds of lexical tokens, where in the out of 7 lexical tokens, we have discussed about the operators, white space, comments, keywords, okay, and all these are comes under the lexical tokens. Lexical tokens plays a vital role in the Verilog hardware descriptional language. So, coming to the white space, what are these white space? These white space can contain characters for spaces, okay. For spaces, it contains some characters, tabs, new lines, and form feeds. So these white space are nothing but they contain some spaces, right? So here in the code, if you see here, earth, after earth you have 2 bits of spaces, 2 spaces, okay. That means what these are nothing but the white space. So the white space, it contains some characters of I mean that after earth 1 might be written. So instead, if you're not writing anything, if it is blank, then it's called as a white space. So the white space can be filled with the characters, it can be filled with the operators, it can be filled with the parameters and as well. So the white space can contain the characteristics of characters of spaces, tabs, new lines, and form feeds. Then these characters are ignored except when they serve to separate tokens. So what happens? What this sentence says is, even though if you find any space, this space can be ignored. This will not come into the consideration. We can ignore itself. Okay. So here there is no space in the beginning of this line. So here, if you observe, there is no space, but there is a space in the string. So this is a beginning and this is a ending, right? So in the beginning, if you see, there is no space. That means the statements itself started with a keyword. Okay, keyword, variable. Register is nothing but a variable. So here, the statement started with a variable, where the variable doesn't has any space, right? Then after this space, if you see, register 8 by 8 into 6 is to 1, address bits, and then earth. Here you have this white space. So this white space doesn't matter at all. Okay. In some case, what happens is, when you are writing some code, we may come across this kind of situation, but it doesn't matter a lot. So here, this particular thing talks about the operators. So this is a unary operator. X is equals to naught of y. So only one operand we observe here, only one operator as well with one operand. So it is a unary operator. Y is a operand and negation is a operator. Then goes with the second one. It's a binary operator. That means Y and Z are 2 operands we have. Okay, 2 operands we have, and OR is a operator. Then the third one is a ternary operator. For this ternary operator, we are considering 3 terms: 1, 2, Y, W, and Z. So these are nothing but the 3 operands. And for these 3 operands, here you can observe this is nothing but the relational. This is nothing but the relational operator, right? So the conditional operator. Question mark is nothing but the conditional operator. And here, see, if you observe the conditional operation, the expression y greater than 5. If y greater than 5, if it is true, then the output goes with true. If it is not, y greater than is false, then obviously output goes to false. So this W and Z are the operands, and with respect to this operation, okay, with respect to this operation, we can able to recognize whether the given statement is true or false. So this is how we can say that ternary operator we can make use of like this. Then Coming to the comments. So what are the comments? In each and every code that you are writing, comments plays a vital role, because comments, it specifies the or else it gives explanation of what you are doing that. So here in the comments we have single line comments and as well as a double line comments. The representation of single and double line comments goes like this. So single line comments begins with the token and ends with carriage written. That means the example here, this is a single line syntax. So it starts with slash, right? Then multi-line or multiple comment begins with a token, that is slash, the star, and ends with a star and slash. Okay, so this is nothing but the multi-line comment, whereas single line comments goes with a plain thing. So this is a single line comment. For example, here you can see this is a multi-line comment. It starts with slash and star and ends with star and slash multi-line, whereas this is single line comment. So this is a particular example. So from this example, we can easily understand how to write a single line and multi-line comment. A single line comment here, see, integer a. So the comment is creates an integer variable called a. So here we are representing the a as an integer, and now I'm writing the comment saying that it is single line comment, right? So creates an integer variable a called a and treats everything to the right of as a comment. So this is a single line comment. So this is a multiple line. So for multiple line comment, I can write like this: ash star and star ash. So see, this is a multiple line block comment. Why? Because it started with ash, it started with slash and the star and the slash. And then see, this is an invalid nested block command. So this is an invalid. Why? Because the single line comment goes like this. Multiple line comments goes like this. Other than this, if you find any sort of comments in between the star or ash repeatedly occurring, then we can say that they are not the comment. Okay, those comments are invalid comments. So for example, this is an invalid comment. How we can say that it is invalid comment? It started with slash star, okay, fine, then ended with slash and again star. So this is nothing but the invalid, so which is invalid comment. And however, this one is okay. So how can we are saying that? So it started with slash, that is a single line comment, and ended with star and slash. So this is fine. But anywhere in the code, if you write like this, the comment, if it is written like this, then it is nothing but the invalid comment. Okay, so there is no meaning in this. So this is all about the comments. Then what are Verilog keywords? So Verilog keywords have special meanings and are called Verilog keywords. For example, here in the Verilog, as I said we have 4 types of cases, or else we have 4 types of abstraction levels that we have to write the code. So by using these 4 kinds of abstraction levels, that is behavioral modeling, gate level modeling, data flow modeling, and switch level modeling. Okay, switch level. So out of this, among these 4, if you happen to write a program with respect to gate level modeling, then this gate level modeling in the Verilog, it has some keywords. So likewise, not only with the gate level modeling, we have keywords with respect to the behavioral modeling, and also we have some keywords with respect to the data flow. We have some keywords with respect to the switch level modeling or circuit level modeling as well. So the words that have special meaning in Verilog are called Verilog keywords. For example, here, assign, case, while, wire, register, and, or, NAND, and, NOR, and module. They should not be used as identifiers. Remember that when you are representing some in the module, if you are representing some parameters, then that parameters should go only as a keywords, but not identifiers. No keyword is acts as an identifier. Identifiers are different than the keywords. Then coming, so here in the keywords, as we are discussing the keywords, there are many different types of keywords we have come across, like module, end module, begin, end, initial, okay, initial, and case, end case. So all these are nothing but the keywords. So out of 4 module, if you are happen to choose any sort of module, such abstraction will have different types of module. But remember that if you are starting with a keyword, it should end with a keyword. Okay, then coming to the continuous assignment statement. So what is this continuous assignment statement? As we all know that assignment is nothing but it is an operator representing with equals to, and on to the left of the equals to we will be assigning the variables or the values, and on to the right of the expression we are obtaining the expression. LH is this is nothing but the assignment operator. So this is an assignment operator. To the left of the assignment operator, we are assigning the variables. Okay, so that variables, it could be in terms of registers, wires, okay, assign, and so on. Whereas onto the right of the assignment operator, we will be able to write the expression. So here in this particular example, you can see the continuous assignment is a main construct to data flow modeling. Okay, that means what? If you are going with respect to the second level of abstraction, that is data, that is third level of abstraction, data flow modeling. Then in this data flow modeling, assign is a keyword that you are using. See, in the data flow modeling, assign is a keyword that you have to mention. In the behavioral modeling, always at the rate block is a keyword that you have to mention. And in the gate level modeling also, SN is a keyword. Okay, so these keywords plays a vital role in all the levels of abstraction. So coming to the assignment, continuous assignment or assignment statement, we say that this continuous assignment statement can be observed while constructing the data flow modeling. Okay, from data flow modeling, and is used to drive assign. That means what? It drives, or else it helps us to write, make use of what keyword assign to the net. So here, and it starts with the keyword assign. As I said you, data flow modeling and gate level modeling, in these two modeling, make use of a keyword called assign. So assign ash 10, 15. So ash is nothing but the delay. So assign delay with 10 and 15, A, which is equals to, A is equals to B and C. So B and C are nothing but the expressions, right hand side expressions, and left hand side is nothing but the assigning the variables. So my variable is A, and my variables are assigning the variables. A is a variable, ash is a variable. That means a delay are the variables. So delays and as well as the variables can be represented towards the left of the assignment operator, and towards right of the assignment operator, the expressions will be written. And then if you observe the second one, assign with the delay operator as 10, 15 and 25. X is the input, right? Y or Z. Okay, Y X nor Z. So on to the right of the operator, assignment operator, I am representing it with the expression, and on to the left of the operator, I am writing the variables. Okay, variables and the delay. So this is how the continuous assignment goes on. So in the code, if you are about to write a code in terms of continuous assignment statement, always remember that after begin you need to assign Y. Okay, assign output, which is equals to assign the output with some delay, the input with the expression, and goes like this. Finally end up with the end module. So here if you observe, assign ash 10, delay, A is a variable, B and C is a expression, and equals to the operator, assignment operator. Okay, so here this is a diagrammatical representation with respect to the delays. So here we have three delays, 10 nanoseconds, 10 and 10 nanoseconds. But my output will is taking its transition at the 10 nanoseconds of delay. Okay, so totally 10 nanoseconds of delay I am able to represent. So this is how the continuous assignment goes on. Then implicit continuous assignment. So there's a difference between continuous assignment, implicit and explicit. So what is this implicit? Implicit is towards the left of the assignment operator, we are representing it with a wire, variable name wire, and that is nothing but the implicit. Explicit is other than the variable name. So here directly I am representing the keyword. So if you are representing the keyword other than the name of a variable, then that such sort of assignment are nothing but the explicit assignment statements. So implicit is it specifies both delay and an assignment on the net. So implicit is here we can represent the delay and as well as a variable. So that means what I can write via with 10 nanoseconds of delay a 1:0 which is equals to x and y. So this is nothing but the implicit. Why I am saying that it is implicit? On to the left of my assignment operator, I am representing it with a variable. Okay, y is a variable name and this is a delay and these are the parameters or also variables. So on to the left, we can specify both delay and as well as the variables. If you are specifying, then it is called as an implicit assignment. If not, if you are assigning by using the keyword, then it is nothing but the explicit assignment operator. When the assignment statement is used to assign the given net with some value, okay, so this is a net with some value, it is called explicit. So explicit is some value you are giving. So you are representing some value onto the variable. That is the explicit. And if not, if an assignment to be done during the net is declared, it is called implicit. So here, this is nothing but the net. Okay, so the net, you are directly representing the net with some value, then it is explicit continuous assignment. If not, if directly you are using some keyword, okay, some net. So why is a net? Then it is a implicit assignment statement. And then data flow modeling. So what is it this data flow modeling means? Data flow modeling, it describes hardware in terms of flow of data. So it just describes the flow of data among the different modules, among the different peripheral devices, from the input to the output. So from the input to the output, the flow of data, okay, the flow of data which is determined is nothing but the data flow modeling. So for example, if you want to describe the AND gate, so the data must flow from the input towards the output, right? So the code goes like this: module, name of the gate is AND gate, and in this port list, in the port list we are representing the input ports and as well as the output ports, and here separately I am describing what are the input ports and what is the output ports. And now as we are considering the data flow modeling, the keyword we need to use, the keyword which is assigned with pertaining to the data flow modeling is assign is a keyword. So I am assigning output. How am I assigning output? Assigning output is nothing but A and B. AND gate, right? A and B. So, and finally I'm ending up with the end module. So this is how the representation of data flow modeling takes place. When you are writing some code in terms of data flow modeling, remember that not to forget to give the keyword assign. Okay, assign is a keyword, and you have to start up with the module, the keyword module, name of the module that you are designing, and then the port list, representations of input, output, and as well as the ports or in-out ports, and finally statements, declaration, and then keyword, declaration, assign, finally ending up with the end module. So these are the few definitions that you will come across in the module 1, and these definitions are very important and easy to understand. If you understand these definitions easily, then it's very useful for you to understand well the whole module. So I hope you all you all get it to know by using from the today's topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.